Now we're going to set up transducers in the software. If I click on the load cell transducer, we will see that this transducer is actually already set up, but I will explain the settings that are in the system. If we go to the Advanced tab, we will see a value for the transducer full scale. It's very important that the actual transducer full scale, as read from the calibration certificate, is input here. It uses this value to calculate the maximum load available on that transducer. So not only will it give us the correct calibration, it sets some safety limits as well. So I have read that 22.377 is the transducer full scale output for this internal submersible load cell. So that must be entered here. Engineering units will of course be kilonewtons for a load cell. Number of decimal places, 3 is reasonable. It's reasonable for this 10 kilonewton load cell, which I have in place here, to have 3 decimal places so that we read to 1 newton. Upper safety limit. This is also very important. Dynamically or statically, if the system increases above the safety limit that we put in here, the system will stop. The soft zero offset is an offset that we can apply to the load cell when it is hanging in free air. So when there is no load applied, and there is no load on the load cell now, so I will reset the zero as follows. On the calibration tab, we need to set the sensitivity. We have help sheet number 125, helps you with calculating the sensitivity. But here, as an example, we have a 10 kilonewton load cell. 10 divided by 22.377 millivolts gives us the kilonewton per millivolt output of the transducer, which we enter as the sensitivity. I can now go to the load cell, take a reading. It's reading 0 nicely because I just set it to 0. The next important transducer to set up is, of course, the displacement measurement. If we go to the Advanced tab on the displacement transducer, we have the information about the encoder. The raw units returned are always counts from the encoder, therefore that's what we see in the software. And the transducer full scale, actually for the encoder, it makes no difference what value we enter here. The engineering units, of course, are millimeters, and the system knows that it's millimeters, so it gives us no other options of what to put. Number of decimal places, 3. Reasonable to be displaying the displacement to 1 micron. So that's what we'll enter as 3. And the soft zero offset will actually zero the encoder in its position. So if we are about to dock the sample or just docked the sample, whatever situation we might be in where we want the encoder to read 0, we can press that. Remember, at the start of a test, GDS Lab automatically sets the encoder or the displacement, whichever is our primary displacement transducer, to 0 at the time when we dock the system. The important value is the sensitivity for the encoder. For the ELDYN machines, this is 0.000208, which is a figure that's calculated from the 6:1 ratio of the drive and the number of lines on the encoder. But your system will be supplied with a calibration certificate for the encoder, so check that in case it is any different from my example. Now that I've set up both of those transducers, the load transducer and the encoder, I'm going to do what we call a sanity check, just to check to see if I may have set the transducers up correctly or not. So I've taken the internal submersible load cell out of the triaxial cell, and what I'm going to do is set the object display to read, and I'm going to push on the floor reasonably gently, but with maybe half my body weight, onto the load transducer, being very careful not to slip. I can see that without too much effort I can push 0.3 of a kilonewton, so maybe 30 kilograms. So that tells me that that's reading about right. At this stage that's good enough for me to know that the transducer's essentially reading the right thing. What we're looking for there is that I don't manage to push 300 kilonewtons or 3 kilograms, something like this, so that we know we're in the right ballpark. The second sanity check we can do is to check to see if we have the encoder set up correctly, to see if we are measuring the correct displacement. It's very easy to get some of these factors a factor of 10 out, so that's what we're looking for here. On the object display, if I now check to see what the current displacement reading is, and we'll see it's 0 at the moment. If I measure here that the RAM is pretty much 140 millimeters from the crosshead, if I come back to the computer and select CP, or control parameter, click on displacement control, and I set a target displacement of 20 millimeters. As soon as I say set target, the RAM will move, hopefully by 20 millimeters. If I take a measurement, we will see that the RAM from the crosshead is now 160 millimeters, so I'm happy. We're in the right ballpark. I haven't measured it particularly accurately, but it's showing me that I'm not a factor of 10, I'm not a factor of 2, it's pretty much 20 millimeters, I'm happy.